Lesson 4.3. What I'm going to do first here is open it up on Power School Learning. So did I say 4.3?
Yeah.
Lesson 2.3. I'm sorry, lesson 2.3. So what does that 2 mean?
Second chapter.
Second chapter. So when you open up Power School Learning here, and I'm trusting that the technology that's out right now is opening up the Power School Learning there. As you open up your Power School Learning and you go to pre-cal, make sure you click on chapter 2 and scroll down to lesson 2.3. That's where we are at today, the Remainder and Factor Theorems. There's 4 tasks to complete today. You've completed number 1, all but 4 people enrolled in this class. You've shown up. Number 2, I hope you've filled out the attendance, which all except 4 have. And now we're at this number 3, in-class work. Go ahead and click that link. And you can start this exam. Do I have open? What's going on? Mine is not. Oh, that's number 2. Okay. You have a question.
There's another one.
Okay, like I said, lesson 2.3. So let's take a look at number 1 here. It says, try to graph this f of x without a calculator if possible and state the leading term. And so this is just kind of a review from last class. But what I want you to know about leading terms. Leading term was the term that does what?
Has the highest power. Has
the highest power. Well, that's in standard form. This right here is in factored form, which is a little bit different for us because we don't have it's not in term form. Remember, terms add and subtract? These right now are in factors. They're multiplying one another. So if I wanted to get my leading term, what I need to do is take the terms within each factor that have a value of x and multiply them. So you see how this is x cubed in the front factor? That is the only x in the front factor is right here. And so in the front factor, it's x, and this factor is cubed. So for the leading term, you only multiply the terms that have x if it's in factored form again. This is factored form. Factored form means they are multiplying and dividing. Factored form. If it's in factored form, you take just the x values from each factor and you multiply them across. So this will be the leading term on this one. What is x cubed times x squared? Would that be x to the 5th or x to the 6th?
X to the
5th, because this is x times x times x times x times x. If you count that up, that's 5 x's. So it would be x to the 5th power. That's my leading term. And so a couple things that we've learned about if you want to try to graph this without a calculator. Why is my, some reason my tools are not working. Let me try this one more time. Refresh it here. There we go. If I wanted to try to graph this on my own, x to the 5th, what can you tell me about from rule 1, lesson 2.1? Is it positive or negative? This will be a positive. What is my a value if it doesn't show 1? 1. So it's positive, which means it's not in the 4th quadrant. Okay, a second thing we could say is its shape off the power. If my power is 5, remember there's 4 shapes. It can curve towards y, it could be a straight line, it could curve towards x, and it can be a C-curve. And here's what they're based off of. If the power is greater than 1, it curves towards y. If the power equals 1, it's a straight line. If the power is less than 1, it curves to the x-axis. And then if it's negative, however, it's a C-curve. Which one's this? Curves towards y because it's greater than 1. And so this would curve towards the y-axis like that. Okay, and then finally, third rule, is this even or odd? And what does that mean? It reflects over the origin this way. So by the way, I didn't say it here. I'll say it again. I haven't said it today, but I'll say it and repeat of 2.1. If the power is positive, a power function will hit the origin. Okay, this problem though was not a power function. So what could we learn from it? Well, we could learn its zeros. And the way you find zeros is you take the inside and you set it equal to 0. This would be another name for zeros is x-intercepts. If I take the inside portions and set that equal to 0, I would find out where this graph crosses the x-axis. If you wanted to solve this one, x minus 2 equals 0, what would you do first? You'd add 2 to both sides. Okay, so we have x equals 2. What about over here? Subtract 1 from both sides. And we find out that x equals -1. That means this graph is actually going to cross through the x-axis at -1 and also at +2. But the first thing, the leading term told us the graph should look like this. We just found it's going to hit at these spots. And then there was something else we learned. So here's what I'm going to do. We learned last class about multiplicity. At the very end, I started talking about it. Here's what multiplicity means. If an x occurs or a 0 occurs more than one time, which in this case, this happens 3 times, that means it has multiplicity 3. Now, what does that do for the graph? Well, it's going to, at that 0, make the shape of a cube. What's the shape of a cube? The shape of a cube. What's the shape of a cube, a third power? An S. It'll actually make an S curve right through that value at -1. It'll make kind of like an S right there. Okay, and then over here, the -1 has multiplicity as well. What's its multiplicity? And what shape does a second power have? It's a parabola, a U. So which means at the 2, you're going to have a parabola. So we're going to have a parabola right there. So my graph should somehow curve back and make a parabola right at 2. That'd be the graph. Now, if you're wondering where would it hit the y-axis, that's when you do the exact opposite of the leading term. Did I say x-axis? I'm sorry, the y-axis. The y-axis is exactly the opposite of the leading term. It's the term that has no x's if you multiply them out. So if you want to know the y-intercept, I'm going to add that in right here. If you want to know the y-intercept, what you would do is multiply anything that does not have an x. So on the front factor, I have a -2 cubed. And the back factor, I have a 1 squared. What is -2 cubed? -2 times -2 times -2. 3 negatives. So it's -8. I agree. -8 times, what's 1 times 1? 1. So it would be -8. What did I do wrong here? -2 times -2 times -8. How's it going to hit -8? We're going to have to graph it and look. I'm going to right click, which for you would be a double click on Desmos. Let's see, why is it not? I'm thinking that it should be positive here. How is it that it turns negative is my question. What did we do wrong? Let me see. F of x equals x minus 2 cubed times x plus 1 squared. Oh, I see what I did wrong. My multiplicity, I did them on the wrong zeros. That's my problem. The cube is supposed to be on 2. The parabola is supposed to be on, hang on, you might have realized that. I put the multiplicity in the wrong spots. Hang on, let me take these away. Let me come back here. You remember how we started with the graph here? Let me totally back that up. I was off here. I was a little dyslexic. So we started here. We had this graph. We found the zeros. So here's how multiplicity works. At -1, it has multiplicity of 2. What shape does a squared have? Parabola. So this piece right here is coming from the left, is going to make a parabola at -1. So this would be the parabola piece. This would need to make a parabola so it hit here and curve down. The y-intercept's at -8. So I'm just going to say -8 is right there. Let's just say that's -8. So this piece would wrap on down and go through there. Now the other 0, and here's our end behavior. We know it's going to end like this. The other 0 has multiplicity of 3. What shape does a power of 3 have? S curve. So it's going to make an S curve going through the 2. So when this comes back up from -8, it should make an S curve like that as it connects to this piece that we knew was going to have right there. And so that's how my picture would look. And that's why I had a screw up, is because I had them backwards. I made this the S curve and that the parabola, but that's not how the zeros were. I was backwards. So that would be your number 1. How you'd graph that without a calculator. Obviously, if the teacher messes it up, it's probably more helpful if you have the graph just to use a calculator. That's how you would do it. Number 2. Any questions over that? What's the leading term again? Highest power. What are some things it could tell you?
General shape of it.
The general shape, which we would call the end behavior. It would tell you the general shape if you zoomed out where the graph would go towards its ends. What else could it tell you if you knew it was x to the 5th?
Maybe an S.
You could have a maximum how many zeros? A maximum 5 zeros and a maximum how many turns?
4.
Or extrema? 4. Let's count this one. This 0, it looks like it only has 2 real zeros, but you would actually count all 5 of them as being real because of multiplicity. You would say this one counts 3 times, this one counts twice. So all 5 would be real. But let's see how many turns it has. 1, 2, really it's just 2. 1, 2. That's not a maximum or a minimum. That's a point of inflection is what they call that. So this would only have 2 extrema. All right. Anything else we learned about last class? No, I don't think so. I think that was it. All right, number 2. So now let's go to standard form. Here we are in standard form. This is where we spent most of the class yesterday. Standard form. So standard form is when all the things are written as terms that are adding and subtracting. What is our leading term?
6x cubed.
The leading term is 6x cubed. Good. And so that right there is easier to find when you're in standard form, although the zeros are not as easy to find. How many possible zeros does this graph have? 3 possible zeros. How many possible extrema, maximums, minimums? 2. Good. All right. First, is this positive or negative, this graph?
Positive.
It's positive. A is 6, which is positive. So which quadrant can I eliminate? 4th. Okay. Secondly, it's cubed. What's it going to do? Curve towards y? Curve type. Okay, you're already answering that. It's going to curve towards the y because it's greater than 1. It'll curve to y. So from the origin, if you zoomed out anyways, it would appear the origin. It'll curve towards y. And then finally, number 3 is 3 odd or even. Does that mean straight across the y-axis or diagonal across the y-axis? All right, across the origin. Across the origin, diagonal. There's odd. Boom. And so again, that's a zoomed out view. If you wanted to zoom in, you would see that it would be shifted up 1. But overall, that's the graph. When we want to do end behavior, that's the limits. So I talked over that last problem. I did not write them down. Let's now talk over our limits. For end behavior, that means what's happening as you go to the left and what's happening as you go to the right. This limit symbols would be given to you. That would be given to you if you were taking a test or if you were on your homework, and all you'd be filling out is this portion right next to the f of x, the y. So tell me, as you go left, does the graph rise, fall, get flat, or stop? Falls. What symbol represents falling? Negative infinity. That's the green piece right there. So I put in green. And what about as you go right? Does it rise, fall, get flat, or stop? Rise. What symbol is that? Positive infinity. That would be your solutions to number 2. And finally, number 3. It says determine all the real zeros. Last class, I showed you how to do that by calculator. The very first day of school, I showed you how to do this by factoring. Which would you prefer me to do in class today? Calculator or by factoring? Factoring. All right, let's do it by factoring. If you ever have to find real zeros, the way to do that is to factor. And if you want to use Desmos, someone in here, please graph it just to check if you wanted to do Desmos. Just graph it so we can check our answers in a moment. The first type of factoring that's the easiest is GCF. Check and see, is there a greatest common factor? All right, what is shared all the way across? X. So you'd factor out the x first. So I'm dividing out 1 power of x. So I'll have x to the 4th minus 13x squared plus 36. So I've factored out the x. I have greatest common factor out the x. It's the opposite distribution. Secondly, I have 3 terms. What technique have I shown you to factor a 3-term trinomial? X method. I'm going to use X method here. Remember, this is your A, your B, and your C. And the way X method works is you take factors of A times C that add up to B. A does not show a number, so I'll put a 1 there. What is 1 times 36?
36.
36. And you're looking for factors that add up to be negative 13. When we were in class, the very first day, I used a technique. I know some students, the numbers pop in your head and you already know the answer and you're like, come on now. But I will write them out in case the numbers don't just pop in your head. I want to write out the factors of 36. There's 1 times 36. There's 2 times 18, good. There's 3 times 12. There's 4 times, not 8, but 9. 10 does not, 5 does not. 6 does. 6 times. And we can stop now. Because the numbers are even, the next one would be 9 and 4. Which we already have that. Okay, I want you to search on there. Which one could somehow give us a negative 13? 4 and 9. Okay, that's a value of 13. How do I make it negative? Both negative. So negative 4 and negative 9. So here's what I have now. We're going to say f of x equals, you still have that x. If you remember, what you do is you split this power. You split the a term's power. This was step 3 that we had. So it becomes x squared. So when I split it, it becomes a squared minus 4. And the other parenthesis is x squared minus 9. You would check to see if you could do bottoms up, but there's nothing that simplifies. So that's it. Okay. Not quite done. I still have a power greater than 1. This is now 2 terms. Do you remember the best shortcut I told you for factoring 2 terms? It's called difference of squares. Give you a hint. Remember how you do it? It's a square root technique, kind of. Yeah, you do the square root. And don't forget about your plus or minus. So the way you do it is each one of these factors, or each one of these squared ones that are 2 terms, are going to become 2 parentheses. So this parenthesis right here, x squared minus 4, is going to become 2. X squared minus 9 is also going to become 2. What is the square root of x squared? That goes there and there. What's the square root of 4? So you'll have 2 and 2. You make 1 negative, 1 positive. That's how you do that. So that right there, this split and became those 2 factors. And now let's split these 2. Do the same thing. What's the square root of x squared? So we have x and x. What's the square root of 9? 3 and 3. Make 1 negative, 1 positive, because with square root, whenever you add a square root that's not originally there, what comes with it? Plus or minus. That's why I went positive and negative. These are my factors. So now that I have this is called factored form. If this was standard form, that right there is called standard form. What we just found was factored form. And we're going to learn on lesson 2.5, the reason you use factored form is factored form will always find your zeros. We'll talk about that exclusively on 2.5. You'll see it some today. But factored form will tell you your zeros. You just set each one equal to 0. I'm assuming we can do a little mental math because we're going to go off of inside lies here. The x is by itself. That means x just equals 0 right there. Here, inside lies now. You would set it equal to 0. So what does this become? X equals what number? 2. You positive 2 when you add that over. Okay, when you set this equal to 0, you have to subtract 2. So what does x equal? Negative 2. Here, what does x equal? 3. And here, what does x equal? Negative 3. So we said at the start, there were 5 possible zeros. Did we have all 5? We had 0, plus and minus 2, and plus or minus 3. That is 5 real zeros.
How do you put plus or minus?
Just write it out as negative 2, positive 2. Just write them out. Yep. And I'm checking my zeros. Sure enough, we got it right. Those were the zeros. The calculator confirms that we did that correctly. So yeah, we did do that correctly. There's a check right there. which that, if you wanted to use graphing technique, you can see that was a lot faster there. If you wanted to do that, you could have done that as well to get your zeros as well. So that's how I would type that in if you're on lesson 2-3. On this one, it just says separating with a comma, just put them in, I think it says from least to greatest. So I would go, let me rewrite this. How I would type that in if I were you, it says least to greatest. Which one of those is the smallest one? -3, comma. And it says comma without spaces, so no spaces. -2, I agree. What's it next? 0 next. 2, 3. List them in that order. No spaces. No spaces, least to greatest. So I'm actually going to move if it'll let me. Whoops. That wasn't what I wanted to click. I wanted to click this one. Oh, it's not letting me move things. Something's wrong with this right now. It's not letting me move. That's how I type it into Power School Learning. PSL, Power School Learning. All right, let's get started on 2-3. All right, lesson 2-3. What are we going to find today? We're going to find out how can you factor when problems get a little bit more difficult. When you can't do GCF, like I just did on number 3, you can't do X method, and you can't do the square root technique, which is technically difference of squares. When you can't do those 3 things, how can you factor? Like, see how this has nothing shared? Look at this problem. Do you see anything shared there? See anything shared? Nope. Is it a trinomial that we can do X method? No. So what can you do? Well, you can do what we call long division. So here's how long division works. It's just like division you learned when you first learned how to divide. You had that house and you put all this inside the house. Some terminology here. We will have this, what I'm writing out right now is called the dividend. The dividend, if you ever hear someone say that, what that means is what you're dividing into. This is the thing doing the dividing. We call that the divisor. The divisor. And then the answer is called the quotient. You got it, quotient. Sometimes we will also have a remainder. Okay, so a lot of times by symbols, the dividend, let me just write that out, dividend. A lot of times we'll take the symbol just f of x. The divisor, you don't have to know all this vocabulary, but just so if you hear me say it, you know what the heck I'm talking about. The divisor, a lot of times will take the symbol d of x. The quotient will oftentimes take the symbol q of x. And then the remainder, oh, I forgot to write quotient. The remainder will take, any guesses on what letter they'll use? R of x, that's right. Okay, so here's how you do that. You take your first term and you ask yourself, what would I need to multiply 2x by to get 6x cubed? Well, let me actually change it up because division and multiplication are opposite. And I said it backwards. What would you need to divide 6x cubed? What is 6x cubed divided by 2x? Let me ask it that way. What is 6x cubed divided by 2x? 3x squared. Now, a lot of people will go down and write that over here, 3x squared on top of the squares. I don't like to do it that way. I like to do it right on top of where I am. And honestly, it doesn't matter where you write it. But I write down directly over the step I'm working on. 6x cubed divided by 2x is 3x. So that's my first term. So what do I do with that 3x squared? Now, I'm going to multiply both these values by 3x squared. So 2x squared times 3x, 2x times 3x squared is that 6x cubed. And then I multiply 3x squared times -5. So what is -5 times 3x squared? -15x squared. Now we're going to simplify. This is the problem where if you're going to mess up, students mess up. When you go to simplify, you see how these are both positives? Are we going to add that and say that's 12x cubed? No, what are you actually going to do? Subtract. Now, when you divide with one term, you do this automatically. But we have 2 terms here. What you need to do, this is the fundamental rule of division, is we need to switch the sign. So not only do I switch this sign, I need to switch the second sign. That's really what people forget. They do the first one right every time. They're like, okay, that simplifies. But what students don't know to do is to switch the sign on the second term as well, which will drastically change my answer. So what is 17x squared plus 15x squared? 32x squared. I call that the fundamental rule of division. And now I'm going to drop down my next term, which is minus 104x. And so now I'm back and I'm asking the same question I asked a moment ago. What would be 32x squared divided by 2x? 32x squared divided by 2x. 16x. And since it's positive, I'm going to do a positive 16x right there. And so now I just multiply it out. 2x times 16x is 32x squared. And then I take my 2x, or excuse me, my 16x, and I multiply it times -5. Anybody know what that is off the top of their head? What's -5 times, if it was just a 10? Oh, good. If it was -5 times 10, it would be -50. And if it was -5 times 6, it would be -30. So what's -50 plus -30? -80. That's -80. -80x. Okay, if I want to combine these correctly, what's the fundamental rule of division?
Change the sign.
I'm going to subtract that, which we automatically do, but I need to also change this sign to a positive as well. So those cancel. And now -104 plus 80 is going to be -24x. Good. I forgot to say the x's, but yes, it's -24x. And I drop my next term down. Plus 60. And so I continue on. And we'll ask the same question one more time. What is -24x divided by 2x? Positive or -12? -12. And so when I multiply this out, 2x times -12 is -24x. And let's see now, -12 times -5 is positive 60. What's the fundamental rule of division? We switch the signs. This becomes a positive. This becomes a negative. They both cancel out. That means the remainder is 0. Remainder R of x. And so the remainder is 0. If your remainder is 0, it is a factor. So this is a factor because the remainder is 0. Since R of x equals 0. All right, it's a factor. So this problem says to factor it completely. Now look at the quotient. Is this quotient factored completely? Do I have another extra page for you to write this problem on? No. You might need a little bit more space, but what I'm now going to do is say, I can factor the quotient. You see how the quotient's a trinomial? Okay, so this trinomial, does it have a GCF? Can 3 go into 16? No. So what I can do here is I can just factor the quotient by using, what technique to use if it's 3 terms?
X method.
X method, that's right. We're going to use X method now. And so now we will factor the quotient. So I'll put this note over here, factor the quotient. And so that's an ugly R. Factor the quotient is what I'm doing now. And so I have the quotient Q of x is 3x squared plus 16x minus 12. And so I'm going to do an X method. A times C over my B. What is 3 times -12? -36. And my B is 16. So I'm looking for 2 numbers that multiply to be -36, but add to be 16. Don't I already have that list? I'm going to go back and copy this list. Except I'm going to take away. Well, I'll just write them out. That's not working for me today. My tools aren't working right. So did you already figure out what they were? 18 and -2. Okay, so I'll write 1 and 36, 2 and 18, and I'll just go ... But we're going to circle up 2 and 18. So how do I make it be a positive 16? You said it's 18 minus 2. I like to reorder it here so it seems in order. 18 minus 2 is 16. 18 times negative 2 is negative 36. Perfect, I agree. Take your A term and you split it. So we would now have that the quotient equals, I take my A term and split it. So I'm splitting this power. It becomes 3x. 3x. Well, I'll just do it this order. 3x minus 2 and 3x plus 18. Before I can say I'm done, I need to do, if your A is greater than 1, you need to do bottoms up. Which parentheses gets simplified? Front, back, or both? So just the back. What can divide into the back? 3. And so my factors would be 3x minus 2, x plus 6. That's actually my quotient. Right there. If I'm going to write out all the factors, let me just do it that way. I'll say it this way. The factors, we have these two factors, and we also were given that 2x minus 5 was a factor. So 2x minus 5. That would be all the factors for this problem. And I could do what we just did and prove it to you by graphing. Check this out. If I graph the original, there's a cheat in here if you're paying attention. I'm not going to tell you the cheat till a few lessons from now. But if you're paying attention, there's a cheat in what I'm about to show you. I just typed in the original equation that was given to me. And if I check my zeros, I get negative 6. Any ideas where the 0, negative 6 comes from? Does inside lie? Okay. The graph also tells me 0.6667. You don't have any idea what that number is? It's a fraction? 2/3. Which one do you think 2/3 came from? The front or back factor? This would equal 2/3. Do a little mental math. If you set it equal to 0, you would add 2, and then you would divide by 3. You would add 2 and divide by 3 because inside lies. Okay, and this last one, any takers on what this is going to be if you did a little mental math? What would you do first? You would add 5, and then what would you do with the 2? You divide it. That's 2.5. Let's check. Does the calculator say 2.5? Looky there. So for those of you who know your fractions well, you can kind of get a cheat on what the answer is going to be based off the calculator. But if you don't know that, just wait a few days. All right, your turn. I want you to try a long division. I want you to try factoring this problem. So you know 3x minus 4 is a factor. What I want you to do is factor this and then factor it and then do a trinomial on what your solution is. So I'll give you a few minutes for this. Now I'm going to talk about those symbols the way I kind of wrote it out earlier. This is kind of what it was saying here, that you have some, we call this a dividend. Some dividend will get divided by a divisor. That will equal some quotient, oftentimes with the remainder, which mathematically, if you were going to write out your equation, the remainder should go on top of the divisor. And so that's just a way you might see it written, or over here, the same thing, that f of x equals the divisor times the quotient plus your remainder. If you have 0 remainder, it's a factor. I'm going to put that on there. If your remainder equals 0, then, then if Rx equals 0, then d of x is a factor of f of x. How about these math symbols? Remember that earlier on this school year I told you my goal is to teach you mathematics. Like you might speak English, you might speak Spanish, you might speak a different language. My goal is to have you be able to speak math by the time you get out of here. This is plain and simple speaking math right there. If the remainder equals 0, then the divisor is a factor of the original. All right. So now I'm going to, it says long division with a non-zero. You know what? I better do this one because it has a remainder. This time we'll see a remainder. So I'm going to do one more long division, and then I'm going to show you a different technique called synthetic. So we have 2x minus 1 dividing into 6x cubed minus 5x squared plus 9x plus 6. And this one just says divide. It doesn't say completely factor or anything like that. The question you ask yourself is, what is 6x cubed, the leading term, divided by the leading term of the divisor? What is 6x cubed divided by 2x? 3x squared. I agree. And so now I just multiply 3x squared by both terms in the divisor. 3x squared times 2x is that 6x cubed we just talked about. But what is negative 1 times 3x squared? Negative 3x squared. The part that if you students are going to mess up, it's almost a guarantee it's going to be on this step. What is the fundamental rule of division? Switch the signs. So the front term should cancel out, hopefully. And now I have a negative 5x squared plus a 3x squared. Negative 2x squared. The 9x, positive 9x will drop down. And we reload. We ask ourselves, what is negative 2x squared divided by 2x? Not negative 2x, negative x, negative 1x. It's okay. No harm, no foul. So it's a negative x. So when I multiply, 2x times negative x is negative 2x squared. What is negative x times negative 1?
Positive x.
Positive 1x. And now we commit to do the fundamental rule of division, which is switch the signs. So I'm going to change this negative to a positive and this positive to a negative. Front term, leading terms cancel out. 9x minus 1x is now 8x, and I drop the plus 6 down. Last step. We ask ourselves, what is 8x divided by 2x? 4. And so 2x times 4 is that 8x. But then I need to take my negative 1 and multiply times 4. What is negative 1 times 4? Negative 4. We need to commit to always do the fundamental rule of division, which means switch the signs here. That simplifies. What is 6 plus 4? I heard it. 10. This is your remainder. Is this a factor? Is 2x minus 1 a factor of this original function?
No.
No, it's not a factor. Not a factor, since I'm going to use the symbols r of x, the remainder does not equal 0. Since the remainder does not equal 0, it's not a factor. So you need to know that. And this would be how you would write the answer. You could say the original, if we called that f of x, you could just say your quotient, it's 3x squared minus x plus 4. The remainder is 10. The way I typically would write the answer, though, you could write it, I think on Alex, your homework, they separate it, and you would write your answer like that. But you could also write your answer as 3x to the 4th minus x plus 4. And then you could write the remainder, that's a positive 10, divided by the quotient, 2x minus 1. That right there would be the solution. So on Alex, though, they would write it as I did. They would separate it as quotient and remainder. But here, I just tied them together like that. All right. You are now going to have a DOL. And so now let's look at dividing one more time, long division, but this time if you're dividing by a trinomial. So everything works out the same. It's just what you're dividing by. The divisor here is longer, which the good news about a longer divisor is it means you get your answer quicker because your steps are going to be compounded together. So you don't have to, it won't take as long to come up with your solution. That's the one benefit of having a longer divisor is right here. We will come up with our answer a lot quicker. What is x cubed divided by x squared? X. So I'm going to multiply this through. What is x squared times x? X cubed. We just said that. What is x times negative 5x? Negative 5x squared. Okay. And what is x times 6? 6x. All right. Now I do the fundamental rule of division. What is the fundamental rule of division? Switch the signs. This becomes a negative. This becomes a positive. This positive becomes a negative. Front simplifies. What is a minus x squared plus 5x squared? 4x squared. Good. We'll have 4x squared. A negative 14x and a negative 6x make a negative 20x. And I drop down my 4. And we are at the stage to get our solution now. What is 4x squared divided by x squared? 4. So I would multiply 4 through. We first get that 4x squared. We know we're going to get that. What is 4 times negative 5? Negative 5x, I'm sorry. Negative 20x. And then what is 4 times 6? 24. We now do the fundamental rule of division, which is switch the signs. So I switch these signs. That cancels. That cancels. 4 minus 24 is negative 20. That is my remainder. So again, you could write your answer, if you are an Alex, as saying the quotient is x plus 4. X plus 4. The remainder is negative 20. Or you could write your answer as x plus 4 minus 20 divided by the divisor, which on this case was x squared minus 5x plus 6. You could write your answer that way as well. I'll circle the bottom. Which takes us to our third DOL. I'll let you divide this one now. All right, now my favorite part of the lesson. There's got to be a quicker technique. Surely we can do this faster. And the answer is yes. Synthetic division algorithm is what the textbook calls it. I just will say synthetic division is a faster way to factor. What you do is this. You take just the coefficient. So look at over here in this example. You're given this dividend and this divisor, x minus 3. What they're first going to do is solve for x. What if x minus 3 is the divisor? What does x actually equal? Positive 3. And so they're going to use 3 and divide in. With synthetic, they do the division, this opposite box, and then they just take the coefficients. Now, this does not say it, but if it was missing a power, you need to put a placeholder of 0 in there. And what was going to happen is we're going to divide like this. Now, this is kind of walking through it. I'm just going to show you on a problem how to do this. So this is a much faster way of dividing. So it says find this divided by x minus 3 using synthetic division. So the first question you must discover if you're going to use synthetic is that in the divisor, what does x actually equal in the divisor? X equals 3. So to use the synthetic, you're going to have positive 3 divided, and this division, you do the sideways, or this, the division box is backwards here. And you're going to write out your coefficients, but check it. Please make sure there is no missing powers. Your powers must decrease sequentially. They must be in order from the largest power, the leading term, down, and there must be nothing missing. Is there anything missing in this problem? 5, 4, 3, 2, 1, and it needs to have 1 without an x as well. We got them all. So we write in the coefficients. Again, let's just say this was a 6. If that were a 6, you would need to put in a 0x to the 5th, which would mean you'd put a 0 right there. But this is not a 6, that's a 5. So I'm just going to write them out. 2, negative 4, negative 3, negative 6, negative 5, and negative 8. I draw one line across. I leave a gap. So here's how synthetic works. This front term always falls straight down here. And what you do, if you've had previous teachers who were able to teach you this before COVID, is what a lot of them say mama, which means you multiply, then you add. You multiply, then you add all the way down. So I'm multiplying first. What's 2 times 3? 6. That goes here. Now you add these together. So -4 plus 6 is 2. And now I multiply again. So it's mama all the way. Multiply, add, multiply, add. What's 2 times 3? 6. Now I add. -3 plus 6, or 6 minus 3 is 3. Now I multiply again. 3 times 3 is 9. And now I add. 9 minus 6, or -6 plus 9 is 3. 3 times 3? 9. Now I add. 4. And then 4 times 3? 12. And I add 4. The 4 is your remainder. The last number is always your remainder. This is not a factor. I'm going to put this out. Not a factor. Since r of x does not equal 0. I want to note that. If you had a number in front of your x here, you would have to divide all these values, not the remainder, but the quotient. This part's going to be the quotient here. You would divide all the quotient by whatever number was in front of x, which we don't. Here, the number is 1. So it'd be like divided by 1, won't change it. So what do I now do with the power? I started as x to the 5th. When it drops down, it drops the power. So it becomes x to the 4th, x cubed, x squared, x, no power. So my quotient would be 2x to the 4th plus 2x cubed plus 3x squared plus 3x plus 4. That 4 is the end of the quotient. This 4 is the remainder. So if you were on Alex, you'd write your answer that way. You could also just put it all together and say your answer is 2x to the 4th plus 2x cubed plus 3x squared plus 3x plus 4, and then plus 4 over the divisor, which our original divisor was x minus 3. That's what the divisor actually was. That right there is synthetic division at its finest. You see how fast we did that? And I wrote everything twice. You honestly could have put your pluses in here, plus and minus, or these are all positives. You could have just put pluses in here and had your answer right there sitting on that line. So it was a very, very quick method. I'm going to do it again so you can see this one more time. Okay, the first thing you need to do if you're going to use synthetic is check what is x actually equal in the divisor. So if you set this equal to 0, what would you do first to get rid of a plus 1? You would subtract 1. How would you get rid of that 4 there? Divide by 4. So our number is -1/4. Our divisor on this synthetic is -1/4. Now we check, are we missing any powers? It goes 4, 3, 2, 1, none. Are we good or are we missing something? We're good. So you write out the coefficients. 8 followed by 38 divided by 5. All right, not divided, followed by 5. Followed by a 3 and then one more 3. There's my line. I'm going to drop my 8 down. You always drop that down. So 8 times, and here's how fractions work if you don't know, because we're multiplying, adding, multiplying, adding. We're doing mama here. Multiply, add, multiply, add, multiply, add. But when you multiply by a fraction, it's actually you multiply the top, divide by the bottom. What's 1 times 8? 8 divide by 4? 2. It's negative, so -2. Now I add this. 38 minus 2 is 36, okay? 36 times 1, 36, divide that by 4. 9, make it negative, -9. I add. 5 minus 9 is -4, okay? -4 times 1, -4, divide by 4, -1, make it negative. 2 negatives make a positive. It's +1. 3 plus 1 is 4. Do it again. 4 times 1, 4 divided by 4. 1, make it negative. 3 minus 1 is 2. This is the remainder. This I would say is the quotient, but it would not be right. You see how there's a number in front of 4? We need to divide the quotient by 4. So not the remainder, but just the quotient. So all of this is going to get divided by 4 to get our answer. So my Q of X. What's 8 divided? I forgot to write this. This was 8x to the 4th. When it drops down, it becomes x cubed. So what is 8 divided by 4? So we'll say 2x cubed. This is a positive. What's 36 divided by 4? 9x squared. Negative 4 divided by 4? Negative 1. It'll be just x to the first. And then what's 4 divided by 4? 1. That's my quotient. My remainder is 2. Do you divide the remainder? No. Do you want me to show you why you do not divide the remainder? Because if you were going to write your answer together, you would write the remainder as being over the original divisor, which means it gets divided right here. 4x plus 1. It gets divided right there. So that's why you don't divide it on synthetic at this step, because when you write it as the remainder over the divisor, that's where it gets divided by 4, right there. How about that? DOL number 4. All right, now the remainder theorem. What this is, I've been showing you all day, is, I'm sorry. If there is a remainder, it's the same thing as if you would have plugged in. Let me just show you in the problem. This is a real world problem. You know that in the past, let's just say, let me read what the values are. It says, suppose 800 units of beachfront property have tenants paying $600 a week. Research indicates that for each $10 decrease in rent, 15 more units would be rented. The weekly revenue for the rentals is given by this equation, where X is the number of $10 decreases the manager is willing to take. Use the remainder theorem to find the revenue if the property's manager decreases rent by $50. So basically, this is what's tricky in this problem. I'm going to underline my variables. X is the number of $10 decreases. And they're saying they want to decrease the value by 50. So you would first need to divide that by 10 because that's what they said it is. X is the number of $10 decreases. So how many $10 decreases do you have? 5. And so have you learned in the past that if you want to do this, you could find R of 5 and just plug in a 5 across? Well, what this remainder theorem is saying is if you do synthetic division and you divide by 5, you would get the exact same answer. But most students just prefer to use function notation and plug it in straight across. And so that's what I'd recommend on that problem. So I'm going to leave that on your own. You could do that to find out. Well, I'll get what this answer is real quick. R of X equal negative 150 X squared plus 1000X plus 480,000. And we want to know R of 5. The answer is use the remainder theorem to find the revenue. This would be the revenue. 481,000. Capital R stands for revenue. Would be 481,250. And so if you did synthetic with an R value of 5, you get the same answer. That's what that theorem was telling you, which I still think it's easier just to use function notation. Do what you already know. Just plug that in there. Okay, so all I did is I just plugged in 5 on this problem. And yours would be the same thing here. But this time, if it decreases rent by $100, what you would be plugging in, if it's X is every $10 decrease, and they're saying decrease by $100, how many decreases is that? 10. So here you're saying 10 is X would be 10. You'd plug that into your solution. But I want to finish this lesson going over this next thing, the factor theorem. So the factor theorem states what I've been telling you the whole time, that if you get a remainder of 0, it's a factor. So here's how I would finish up this lesson, is saying this. If you are going to try to use the factor theorem, determine if two things are factors, pick one. It doesn't matter which one. Pick one to go first. Which one do you want to test first? X minus 5 or X plus 5? Here, minus 5. What does X actually equal here? 5. Okay, so if you're going to check to see if something's a factor, use synthetic. I think it's the easiest way. I've solved for my power first, or my divisor first. Now check your powers. 3, 2, 1, none. Am I missing any? No, so I'm going to write them out. 1, negative 18, 60, and 25. Yes, sir.
What happens when you are?
You throw in a 0 in the place you're missing. If you're missing a power, you put a 0 as a placeholder. So like if this was a 4, I would put a 0 for X cubed. I would put a 0 in right there if that was the case. But this is not missing any powers, so I don't have to put a 0 in the placeholder. 1 drops, and I do mama. I multiply, add. What's 5 times 1? Now we add. I get negative 13. Multiply. Getting negative 65. Add. Negative 5. Okay, y'all can tell me, what's 5 times negative 5? Negative 25. Would this be a factor?
Yes.
Okay, this is a factor. Now, if the equation is a factor, you can test the next on the same line. If it's a factor, you can continue on straight from the quotient here. So I could say X equals negative 5, and I could start right over and test negative 5 right here. I would not need to start the whole problem over. I could go straight from this point. So what is 1 times negative 5? Negative 5. I add, I get negative 18. Negative 18 times negative 5 is positive 90. This right here, when I add them, I get a plus 85. This is now my remainder. Is this a factor? Not a factor. What does that mean? That means X minus 5 is a factor, but this X plus 5 is not. So the factored form, we know X minus 5 is a factor, and I would just write this quotient that I had right here. Times X squared minus 13X minus 5. That would be my factored form. I know this was a factor, but this one was not, so I would not include that. That's how you can use the factor theorem. All right, let's try this a second time. Let's see if we can do this all over again. So I want to determine if X minus 5 and X plus 2 are factors of f of X here. So let's just use X minus 5 first. We'll say this is, or we'll solve it for X. And so if you solve this, set it equal to 0, you'd have to add 5. We find out that X equals positive 5. That's why we say inside lies. So I want to see if 5 can divide into this function. So it's 1x cubed. Let me make sure I'm not missing powers. Squared 1. Okay, I got all the powers. So 1x cubed minus 2x squared minus 13x minus 10. Leave myself a space. I'm going to drop this 1 down. 1 times 5 is 5. So I multiply, and now I'm going to add. So this is really adding positive 5 minus 2, or negative 2 plus 5 would be positive 3. Now I multiply. 3 times 5 is 15. And I'm going to add this. So negative 13 plus 15 is a positive 2. And I multiply again. 5 times 2 is positive 10. And I see that I get 0. According to the factor theorem, if your remainder is 0, this is a factor. So X minus 5 is a factor. Okay, that's good news. So if it's a factor, you can use this simplified form of f of X. So the quotient here becomes our new equation that we're going to work with. It was f of X originally started with cubed. It was its leading term. Now we're going to say it's X squared plus 3X plus 2. And so now I want to factor over here, and we're going to try this factor next. And so this would be X equaling negative 2. And so since this was equal to 0, I'm going to use this. It's kind of like if you're a video game person, like if you hit a checkpoint And after that checkpoint, a lot of times if your person you're playing with perishes, you would be restored at the checkpoint. This is kind of like that checkpoint. So you can now start with -2. And if -2 does not work and you had a third option, you could start the third option right from this point. It's kind of like a checkpoint in that regard. So I have 1, 3, and 2 that I'm checking from. And 1 comes down. 1 times -2 is -2. 3 minus 2 is a +1. And when I multiply that, I get -2. And again, I get that this is a factor. So if this is a factor, let's see here, x plus 2 is a factor. What's left over now, we had started here at x squared. This has become an x. We can see that I'm down to my last linear factor because that's just 1x plus 1 or x plus 1. So I could rewrite f of x in factored form and say f of x is going to equal x minus 5 times x plus 2. And this is now my new checkpoint, if you will, what's left over, times 1x plus 1. That right there would be my function f in simple factored form. All right, so where the previous problem would not simplify, and if you had another third term here, so they only gave me those. Well, let's just say there was an extra term we were supposed to try. Since this had a remainder, I could not test it from here, but I could come back to this right here that was a factor and go and test that one. This started as x cubed, so I would be starting from like 1x squared minus 13x minus 5 and saying that's like my checkpoint. Let's say we were going to check another. You would check from this right there. Since that had a 0 factor, you could just do shortcut and start from right there. All right, now that I've shown you these two, I will let you try these two, or test these two factors, or test to see if these two binomials are factors. And if they are, what would it simplify the equation to become? All right, now let's check out some spiral for review. Let's take like an ACP type problem. We have seen problems where it says find g of f of h, and this one actually says what is g of f of h of 4? And I want you to remember that whenever you see this, this ultimately means you need to do substitution. And so that's what I'm going to do on this problem is I'm going to stack these equations and I'm going to substitute. So first comes the equation g, 2x squared, then is f after that, which is 3x plus 2, and then h, which is x minus 2. And we're going to substitute in a -4. So the -4 is going to get substituted in instead of x. And I forgot to put the o's there. And so this would be g of f of h of x, but we're saying x equals -4. So usually it's g of f of h of x. Instead of this one, it's we're saying x equals -4. It's an ugly x. Let me do that again. There we go. And so that's going to substitute in. That is going to go in right there. And so we are saying that h of -4 equals -4 minus 2 more would be equal to -6. So now I'm taking that -6, and what I'm going to do with that -6 is I'm going to substitute in for this x right there. That x is going to get substituted with -6. And so that means that f of h of -4 would equal 3 times -6 plus 2. If I go to simplify that, 3 times -6 is -18. And then I would add 2. And -18 plus 2 is -16. So now I'm going to take this -16 and we will substitute that right here in for this x, which means that g of f of h of -4 will equal 2 times, substitute the -16 in for x, negative 16 squared. And if I just type in the calculator, I believe I'm gonna get 512. So 2 times negative 16 raised to the power of 2, it is 512. 512, that's the solution there, 512. Okay, down underneath it, we have the transformation problem. It says f of x equals x cubed is changed to all of this. How's the graph been transformed? Well, I see I have an inside transformation and outside. Now remember our two rules. The first one is HIVO. Horizontal's inside, vertical's outside. And the second rule is that the inside lies. That inside lies. Let me put a 1 here. That's rule 1. Here's rule 2. Inside lies, outside tells the truth. So this plus 2 is inside, which means if it's that plus 2 is inside the parentheses, inside the cube, it's horizontal. So this is horizontal. That means left or right. Anytime you add or subtract, it's a shift. And according to this, inside lies. So plus 2 is actually going to go negative 2, which means it'll go on the horizontal axis, left 2. So I can eliminate 2 options that say move. Translate is the same thing as shift. So it needs to go left. And then I have over here a plus 1. Now I can see that that plus 1 is outside the parentheses. So if it's outside, it's vertical. And anytime you add or subtract a number, it's a shift or translation. And outside tells the truth. So plus 1 up is up 1 on the y-axis. Which means my answer would be H here. Now finally, last little ACP problem here. Oh, no, that was it. Let's wrap.